So until now, what we have done is we loaded the data, we saw problem definition, what we need to do with the data, we loaded the data, and our main task is to just see the difference and similarities between these comedians, how they perform and everything. So first of all, we load the data, then after we talk about how to combine the text and we convert that into the pandas data frame. Now our data is into the format from where we can start to clean our data. So cleaning the data is basically when we deal with the numerical data. Data cleaning often involves removing null values and duplicate data, dealing with outlier and etc. This was what we did in the project 1 because there was a numerical data. We removed the null values or we removed the duplicate data, we handled the outlier and everything was done in the project 1. But now it is a textual data. It is no longer numerical data. It is a text data. See here, these are all the text. These are all the transcript of the comedians. And we human speak in the strings. We don't have the numbers in our language. So our natural language is a string, a collection of bunch of a sentence, and that is the text data. So whenever we deal with the textual data, there are some common data cleaning techniques, which we often call it as text pre-processing techniques. With textual data or a text data, this process can go on forever. So it is long running process. There's always an exception to every cleaning step. So we are going to follow the minimum viable product approach. So this is the product approach or minimum viable product approach that we are going to just have in our project. That is, start with a simple process and do the iteration. So here are the bunch of things that we need to clean on our data sets. That is, first of all, we have to make the text into the lowercase. This is because we want a generalization. See here, some of the word are in that is uppercase, some of them are lowercase. So we want to give all of them the common weight. So that is the reason we need to convert it into the lowercase. We can also remove the punctuation so that these punctuation are no longer useful onto our analysis. So we can remove them. And next is we can remove the numerical values. Since we are dealing with the textual data, we no longer require the numerical values. We can also remove common nonsensical text like this /n. See here in our data there is so many /n right here. So this should be also removed. And next we need to tokenize the text. So what do you mean by tokenize the text? Tokenizing the text means you are going to have each word as a token. So you are going to take each word as a token, and that is a process called as a tokenization. And similarly, we need to remove the stop words. So what are the stop words? Something like preposition, maybe conjunction, and so that. For example, see here the pronoun. So I have the pronoun they, and I have something that is like noun, pronoun. These are not important for our analysis, so we need to remove them. See here some of this text. So what we really interest on this text is like verb. We are also interested in the adjective, verb, and so those text will be important for us in order to get the meaning. I don't really want those information like pronoun or maybe noun. Those information will just clutter our analysis, so we don't want that. So that is the reason we want to remove those stop words. If you do not know about the stop words, they are those words that doesn't have actual meaning, but they come into the sentence in order to complete it. So those might be not so much important for our analysis, so it is better to remove those. And more of the data cleaning step can be done after tokenization, like stemming, lemmatization, POS tagging, bigram, trigram, and deal with the typos and many more. So these are all the data cleaning process that we can do while handling the textual information. We are going to do some of these upper ones, and I will just leave this to you. You can search it out. I'll give some resources, and these are some of the techniques that you can do onto your data cleaning process in order to make our model more accurate and our data more clean. Now let us go down and let us start to perform the data cleaning step. So for that I want the regular expression. So RE stands for a regular expression. I will also import strings in order to handle some method related to the string. So let us import both of them. So let us run it. So after running, let us go down here. Maybe I can make some of those cells. So now I'll define a function that will clean the text for me. Clean text. And this will just take a text that needs to be cleaned. Now the first thing that I want to do with this text is I want to make it to the lowercase. So I will call just lower. So see here, the first step is to convert our text to the lowercase. So this function will convert it to the lowercase and it will assign back to the text after we convert it to the lowercase. Next is I want to remove maybe the text that have this square brackets into it. I did saw it, maybe it was in the case of Ricky. Some of them have this square brackets into it, so I need to remove them so that this text might look uncluttered. So I'll take the text and I need to use this regular expression to define the patterns. So I'll just use this regular expression and I'll just say sub. Sub here means substitute. So what I need to substitute is, let's say I'll give the pattern to it now. So slash and the square bracket, and inside this square bracket I might have any number of characters inside this square bracket, and let us end it with another slash right here. So this is my pattern, and whenever I saw these type of things, I'll just replace it with a single, that is, let's say just replace with nothing. So basically I will not even give a space, and let us pass here text. So basically if this module, this function finds this pattern, it will be replaced by this onto our text. And what does this pattern represent? This pattern represents to remove the text in the square bracket. So basically this is the square bracket right here. So if we found something like this, for example, I have hello, so something like this, then this will be replaced by nothing. So it will be empty because we haven't passed here anything. Maybe if I put here A, then this would be replaced by A. But here I won't pass anything, so that means it will be empty. We will just remove this. So just remove any text with square bracket. So this cleaning of the data is dependent upon your data itself. So see here, some of the data have this punctuation, maybe some unusual text. You can just search it out and you can text or pre-process by our manual code. So it completely depends upon the situation. You cannot generalize this process. Now next is I want to remove the punctuation. There is so many punctuation, so I'm going to use the regular expression substitute method, and I will pass here, that is, let's say I will have this square bracket and any number of string here, and this will be re.escape, and here I will pass the string dot punctuation. We have already imported the string, so from string module I have taken out the punctuation. So if the punctuation is found onto our text, it will be also replaced by nothing onto our text. So this line of a code will try to find the punctuation onto our text. Now next thing is, let's say if I want to remove maybe word containing the numbers. There are some word that might contain the numbers. You can search it out there. So if the text contain the numbers, I want to just replace it with nothing. Basically I want to remove it. So for that the pattern is /w. So that is a word here, a string, and we might have any number of word. After that I might have this digit, so D here is for the digit or the number, and then again I might have any words. So this is the pattern. So this asterisk means any number of the words. It can be either 0 or 1 or 2 or any number of the words. So this is the pattern right here. So /w represents the word or the string, and /d represents the digit. Now if we found any digits or the numbers that is within the word, we need to remove it. So I'll just substitute with this and I'll just pass text, and after doing it I'll just return the text. So this is all we have. And let's say this is a round 1 cleaning, and I'm going to pass lambda. This is an anonymous function. You can check it out. What does this anonymous function do? Now I can call this clean text function and pass x to it. So basically I'm passing the x to it whenever I will call this lambda function. So here I need to first of all call this function and run this portion also. Just run both of these code. After running it, now let us look the updated text. Let us update our text now. So for that I'll just say data clean after the data is cleaned, and I'll store it in the pandas data frame. So I can directly create a pandas data frame. And if you remember, previously our data was named as data_df. So this was our previous name, which is uncleaned. Now data_df was uncleaned, and we gave it to this clean data. And what needs to be cleaned? Transcript. So inside the data frame, because if you check data_data frame, it contains this first, which is a comedian name, and the transcript. So transcript should be cleaned, not the name of the comedians. So I pass the transcript, and I will pass .apply because I need to do it for each and every transcript of the comedian. So I'll pass round 1 to it. See here, this round 1 is the lambda function. So it is passed right here. Now after that I can check data clean. Now let us run it, and you can see now something has been removed. Let's say all the things has been converted into the lowercase. You can see all of them are in the lowercase. I can also get the transcript and location, let's say for Ali. Then you can see this is the transcript. All of them has been converted into the lowercase. Some of the punctuation has been removed, not all. You can see we have a punctuation right here, but some of the punctuation has been removed, and extra spaces has been removed, and maybe the numbers has been also removed from here. So this is what we need. We basically have cleaned. So this is the first round of a clean, and I have already stated here we are going to take an approach of minimum viable product. Basically we are going to start with a simple one, and we are going to iterate again. So basically we can have multiple steps for cleaning our data. So it's up to you how much round of cleaning the data you want to take. So it is completely dependent upon the programmer who wants to build this model. Now next round, I want to do the next round because I just found that our data was not perfectly cleaned. So I'll just say clean text. It is round 2. And here I'll just pass the text again. And now in the text, what I can remove is, I can remove something that is right here. If I go back, I just removed it, I think. If I show you the clean data, previously clean data from the round 1, and transcript is what I want, and location of Ali. So let us run this. Then you can see some of them have this type of quotation. So this type of quotation should be removed now. So in order to clean them, I'm going to use the substitute method from the regular expression, sub method, and this will take the pattern that this function will search onto our text, and I want to give this pattern to it. Like first is this quotation mark, and I want to give the double quotation mark if it founds this type of text, and even this dot dot dot. If it founds this type of text, then I want to remove it. I want to replace it, in fact, and I'll just pass here text, which needs to be replaced. Next is the nonsensical information. You can see there are some /n right here, so I need to remove it also. So re.sub, and if I find this /n onto our data, I will remove it into the text. So I'll just replace it. So the first argument is a pattern to be searched, and second one is the replacement. So whenever we find this, we replace by this. And next is to return the text. This will be enough in my case. So this is round 2 for cleaning the data, lambda of x, and the next round is clean text. Round 2 is the function. Let us pass the text to it, or in fact this is the x argument. Now everything looks fine. We have created a method where we can remove these double punctuations here. I have kept the single punctuation, double punctuation, and this dot dot dot. You can see right here, I have found in one of the script, like see here, we have this continuous dot dot dot. I thought I just found here, and it is right here. See here, in this we have these 3 dots. So I'm going to remove it. In fact, it is 4 or 3. It has 3 dots. So if it finds these 3 dots, then it should be also removed. And this way, now let us run it. Let us go down and let us call this round 2 in our data clean. So pandas.data frame, I want to store it in the data frame, and I will call the data clean, previously clean data from the round first. We are going to use that data, and we are going to again call the round 2 on the previously cleaned data. And what needs to be cleaned? Only the transcript. I don't want to clean the comedian name, so only the transcript should be cleaned. And let us put the round 2. So this apply family of function will perform this round 2 for each of the comedians. So that is the reason we use the apply function. Now finally, if I check the clean data, then I got an error because this should be equal. Now let us run it. Now see here, so double quotation mark was removed, I guess. So let us check the transcript of one comedian, transcript dot location, and I want maybe of Ricky Gervais. When I run it, still you can see Some of them is right here. Maybe /n was removed. Still, it has not been cleaned that much. So maybe we can do something like maybe add another round if we want. But I guess round 2 would be fine. We have a little to next. So these are the information that should also be removed. Maybe in the case of some comedians, we have this extra unwanted information. We can remove this also. So I'm going to find this now. So we have these numbers. This should be removed, but it is right here. So I'll just take it, I'll paste it, and if we find these patterns in our text, where did it go? It is right here. This text in our pattern, then I'm going to replace it with nothing. So let us run it. Okay. So here the problem is of indentation. I can just remove this extra space. I can run it. Now I can again call this one. Then those text, if you see, this was also removed. So this way you can manually process and check what are the things that you want to remove from this text, and you can have different round of cleaning this text, because we have already said this cleaning of the data is iterative process, and this is going to go forever. So that is what we did here. We only saw 2 steps in fact in our case, but this might go longer in the real world scenario. Now from next video onward, we will see how to organize this cleaned data. So before that, I want to show you another or further steps of data cleaning. Up till now, we have only been doing this common data cleaning step, but more advanced steps are right here, like stemming, lemmatization, part of speech tagging, creating bigram, trigram, and dealing with typos. These are the additional data cleaning step that you can search and that you can learn. I'm going to talk about the stemming here. So what does stemming do is, let us take example of stemming. So let's say I have the word creating. So this is the word creating. You can see this is V4. So if I convert it into the V1, verb 1, that is only the create, the root word of this verb is create. So this process is called stemming. So this is a stemming. We can also do something called as lemmatization. The process is quite similar. I want you to research on this topic, but for this particular course, we don't really want to go deep down into this process. Rather, we will surfacely learn this process, and these are the further steps that you can do in order to make your data more clean. But we have already seen the common and most popular steps for cleaning the data, which is normally the textual data. If you want to explore the further more steps, if you want to learn about the deep neural network, and if you want to learn how to process the text using more advanced neural network and maybe LSTM model, then this step must also be done. But for this particular course, we won't be doing the deep neural network, so that is the reason maybe these steps might not be vital. But if you have any interest, then please go and search these concepts of data cleaning. This might be also vital if you want to make the model that is more robust and more accurate. So that is all about cleaning the textual information. We normally use a simple library, which is regular expression library here, and we substitute the pattern with our own string that we want. So basic steps are like removing punctuation, removing numerical value, removing nonsensical text. So these are the most popular and common data cleaning step, and we have already done some of them right here. And these processes are iterative, as I have already told you. If you want any other round of text cleaning, you can also do it and make our text more cleaned. But for now, this will be enough. In the next video, we are going to organize this data into something called as a document term matrix.